All right, hey guys. So today we're gonna go through the notes for our next unit, which is Unit 18, is about solid waste. So the notes over 18.1, the solid waste problem. Um, there's actually quite a bit in this first section of notes, so I'm gonna try to tag different timestamps in the description for this video, so you can jump to um, different parts if you need to go back and listen or look it up later. Okay. So the beginning of this starts off with some statistics. Excuse me. So, sorry to grab something. Definition: municipal solid waste is the total of all the materials, typically called trash, refuse, or garbage, thrown away from homes and commercial establishments. So in 1960, average trash production was 2.7 pounds per person per day. In 2003, average trash production had risen to 4.5 pounds per person per day. And then I just kind of updated our statistics. In 2019, average trash production was 4.9 pounds per person per day. So I just did the math out so you can kind of get an idea. This is approximately 1,788.5 pounds per person per year. And a family of four would produce around 137, almost 140 pounds per week, or 7,154 pounds per year for an average for a family of four. Okay, now you might look at this and think like, well, I don't throw away 5 pounds of trash a day. You know, if you kind of monitor what you throw away and stuff, you're like, I don't, like, we don't throw anywhere near that, right? Well, what you have to remember is this is the average per person of all the MSW that we produce in the United States. Okay, so this isn't just what you're throwing away at home. Okay, think about stuff that gets thrown away here at school. Okay, that has to get counted into it. So even stuff that you don't throw away here at school, so if it's stuff that teachers throw away, or if it's stuff that just the school in general throws away, um, old desks, old, whatever it is, that all gets counted into the average. So businesses, trash from industry, and industry and factories and manufacturing and stuff. All of that gets counted into the MSW, and the average then comes from all of that. Okay. All right. Um, the United States actually, in comparison, I was going to show you guys something here. Let me see. Um, the United States. Ooh, why did this pop up? Okay, here we go. So this is not letting me see it now. Okay, well, it doesn't really matter. Um, the United States is number one in MSW, uh, all over, like compared to any other country. So let me see if I can get this without something that you want to pay for. So the United States is number one, with China and India behind. Now you'd probably, that makes sense because the most people, right? Okay, so um, here, waste per capita. Okay, let's see if I can pull up one that um, one statistic wanted me to. Let's see. Here we go. Oh, this is something different. Okay. Well, we're not going to worry about it. The United States is number one overall um, in production, and so it is a big deal. Okay. Uh, all right. So what is the MSW, municipal solid waste? What is in municipal solid waste? So in the United States, these were the most recent breakdowns I found last year. 27.4% of all the trash, okay, the solid trash is paper, paperboard, or something like that, cardboard, that kind of stuff. So almost, I mean, think about that. That's like close to 30%. Okay. A little over a quarter is paper, paperboard, paper products. 14.5% is food waste. Okay, so yes, this includes like people throwing out leftovers at home and stuff, but it also includes things about restaurants and stuff. If you ever worked at a restaurant or you know anything about them, that like most of them they don't keep their food from one day to the other. They can't. It's that's not sanitary and it's gross. So they would throw it out at the end of the day, right? Anything that wasn't eaten. Um, this one kind of surprised me when I first saw this. 13.5% is yard waste. So yard waste would include anything like leaves or tree trimmings, and so think about that. The third largest contributor to the trash that we throw away is yard waste. Okay? That's pretty crazy when you think about it. That's actually going into landfills. 12.7% is plastics. 8.9% is metals. 8.7% is rubber, leather, and textiles. So you know rubber and leather. Textiles are like any kind of like fabric. So whether it's um, like fabrics from clothes or whether it's like rugs or drapes, anything like that is considered a textile. 6.3% is wood. And so I'm assuming this is different from like yard waste. Wood from yard waste would be up here, but this would be wood like if you're throwing away like wooden chair or stuff like that, I think. 4.6% is glass, and 3.4% is what they've categorized as other. Okay, so usually every year when we're together, I go through this and I have you guys we try to figure out together like, okay, this is all the stuff going into landfills. If we have other categories of stuff like there's recycling, composting, reusing, and landfill, and then some of it going into landfills, like what could we do? What of these things could fall into these other categories instead of all going into landfills? So what we've come up with before is the things that could be recycled would include um, the paperboard. Could be a lot of that can be recycled. Not all of it, because some of it eventually you can only recycle it so many times. But um, plastics, some plastics can be recycled, not all, but some. Metals can be. Almost all metals can be recycled. Glass can be recycled. Okay, so trying to keep it sort of realistic. Uh, all right. What about composting? Well, the big one and most obvious, I'm going to slide this under here so we can hopefully see the coloring better. Okay. The big one and the most obvious would be the yard waste, right? The yard waste that can be composted. It would normally decompose in nature anyway. Food waste, and not all food waste, but a decent amount of food waste can be composted. Okay. Let's see. What about? I don't think none of this can be plastic. No, no, no. Wood. Wood a lot of times can be composted or somehow done. Glass cannot. Other. Okay. So those could be composted. All right. Reused. So reuse could be repurposed. You could reuse it for something else for a different purpose. Uh, or it can actually be reused. Like, so for example, um, glass, sometimes when they recycle glass, they actually crush it up and use it as part of a paver base for asphalt in roads. And they'll do that with other things too. So like reusing it in large quantity amounts too. So glass can be um, rubber, leather, textiles. Think about like rubber, like reusing rubber in tracks and like artificial turfs now that they're using stuff in. Some of that can be reused. Um, some plastic can be reused depending on what you're doing with it. They've got the t-shirts and stuff. I actually have one. Says this shirt used to be trash. They can make clothing out of like plastic bottles and stuff like that. Plastics now. So recycling, reusing. I don't know really which you want to call it, but I think it's technically reusing it because it's. I don't think you're going through the process of recycling totally. Okay, and then what would be going into landfill? So maybe some of the food waste that can't be composted, some of the plastic that can't be recycled or reused, some of the rubber, leather, and textiles that can't be recycled or reused, and then the other. So this is just, and this was just us, just kind of thinking like, well, potentially, what could we do with the trash that gets thrown away? Okay, so MSW disposal in the United States. I don't remember what year this was. I tried to update them relatively recently, so I think this is within the past like 5 years. 228 million metric tons. 54% of the MSW that we produce goes into landfills. Okay, so not all of this goes into landfills. 123 million metric tons, so a little over half of it. 37% goes through recycling, not too bad, and 9% goes through combustion, which we'll talk about in a little bit, means burning. So the 123 million metric tons is about 3,640. Oh, I know what I did. Okay. So I took, this is actually an old number. Hold on. 17. This is, that can't be right. Okay, I'm going to pause this real quick and make sure this is right. Okay, sorry. So yeah, this was the old number. So what I did is I took the 7,154 pounds per family per year, and I just multiplied it to see about how many pounds. So of the 7,154 pounds per family per year, about 3,863 of it ends up in landfills. Okay, 37% recycling, 9% combustion. If we did what we were kind of potentially thinking we could maybe do with some of this, all right, what would we end up with? Well, we could end up with somewhere around 54% recycling, 30% composting, and maybe only 16% in landfills, which would be 1,145 pounds per person per year, or sorry, per family per year, family of four per year. So the difference is we could theoretically save around 2,718 pounds of trash going into landfills per family. And if you think about it, that means that like it would take over 3 years to put the same amount of trash in the landfill that a family of four is putting in 1 year right now, if we were able to reduce it like that. Okay. All right. So that's kind of the basics and some stats on your trash, MSW. All right. Now, landfills. Okay. This has to do with the decomposition landfill activity that you guys have been working on too. So landfill types. There's two basic types, okay, that we're going to talk about at least. There's open air landfills and there's sanitary landfills. Open air landfills are an older style of landfill. Typically, all the refuse is piled in one area with little or no covering. Okay, so I have some pictures. Okay, this is a picture of, this was the world's largest open air landfill in Rio de Janeiro. So there's some pictures of the landfill. So literally all it is just piles of trash, piled up, no covering, nothing like that. Okay. So that's an open air landfill. All right. So what I've done is sort of listed benefits and drawbacks to each type of landfill here. So benefits of open air landfills are convenience, super convenient, just throwing it all in a pile in a hole or piling it up. They're cheaper to maintain, and you actually get faster decomposition. Okay, we'll go back to the faster decomposition one in a little bit. Drawbacks: pollution. There's a lot of pollution from open air landfills. Pollution can get into water sources. You get trash transfer to surrounding areas. You get the air pollution from burning. Sometimes the gases and stuff can catch on fire. Okay, you get leachate. Leachate, down here I have the definition. This is not another type of landfill, it's a definition. Leachate from water or rain is where water, rain, whatever, mixes with trash and dissolves many substances into the water. So you think about it, water can dissolve a lot of stuff. Well, when it rains or water somehow gets into the trash, it can dissolve a lot of different things in there. And then it says leachate is typically very environmentally hazardous, especially if it reaches groundwater sources. So what happens is the water dissolves a lot of things, and some of them can be potentially harmful in the trash. And then because it's now dissolved in the water, as the water works its way down through the trash, it can carry these hazardous substances through it, and they don't filter out because they're dissolved. Right? That's what leachate is. So that's a big drawback for open air landfills. They have a large space requirement, and they can attract animals and scavengers. So you saw in that picture actually birds all over. Okay, there's also other kinds of animals, tons of different animals that will scavenge and stuff like that. Okay. And siting issues, where to put them. Obviously, nobody wants that anywhere near where they would be living. Okay. So the open air landfill is like the one that we were doing with the activity was the one where you just buried everything right in the dirt. That represents kind of an open air landfill. Okay. The sand one is also not open air, but that's with drier soil. That would be like in a drier climate or atmosphere. All right. Okay. Sanitary landfills. This is the newer style of landfill. What we mainly use these days. These are designed to eliminate most pollution. It keeps trash in separated quote unquote cells and has a plastic liner system to prevent groundwater contamination. Okay, there is a picture in your book. I've got a picture pulled up here to show you guys. So they have you can see the trash is separated into cells where they're then covered with dirt and compacted, but you can see the different layers of this. You've got a compacted clay layer on the very bottom, which prevents water from transferring through it. The clay is really dense and water doesn't transfer through it. Okay, then you've got an HDPE, it's a high density polyethylene liner. So essentially this red area here is the liner underneath that. Okay, then you've got what's called a geotextile. It's a non-woven fabric that acts as a protective layer above the plastic liner. It provides protection or cushion to the plastic liner from the granular layer above. So this granular layer helps funnel leachate, remember the potentially hazardous liquid, to the leachate collection system. So this would be like a layer of like gravel, sand, stuff like that. So liquids can filter through, but it kind of acts as a filter. And then that textile mat protects the plastic liner from the gravel layer, sort of the gravel sand layer. Okay. Then you get a soil protective layer. So all these layers are below where we're actually putting the trash. Okay, so they put the trash in, and then you get a daily cover. You get the different cells, and they're covered with dirt, each of themselves, and then daily 6 to 18 inches of daily or intermediate soil cover is placed down in between each one. And then you get another one going. Then when you're capping it off with similar liners to down here, and then you're capping it off with dirt and soil over it. Now they've also got this leachate collection pipe where it allows leachate to drain down through the landfill, but then it funnels it off and takes it either to leachate collection pools or leachate collection tanks, where it's treated and any hazardous materials are treated and pulled out and sent to a wastewater treatment facility. Okay. Now, one thing that this doesn't really show, I don't see anywhere on it, but it is in the one in your book, so I'll flip back to this, is most of them also now have, they all have monitoring wells, which are these wells that are placed around the landfill, and they're drilled down into the groundwater to make sure that nothing hazardous or poisonous from the landfill is getting into the groundwater, and they do their testing through that. Okay. All right. So benefits of sanitary landfills: much less pollution. There's no leachate contamination of groundwater. Okay. Drawbacks: they are more expensive to maintain because there's more that goes into them. They're less convenient. They still have siting issues. Nobody wants a landfill near them, even if it's better to have a sanitary one than the other, but nobody still wants them near them. And you get slower decomposition. Okay. Which we're going to talk about down here, about why that is down here in the main problems of landfills. All right. So, main problems of landfills: leachate creation and groundwater contamination. We already talked about that. This is also why there's laws about the kind of stuff that you can throw into your trash. Like you're not supposed to throw oil into your trash and other stuff like that because of the potential for it to contaminate groundwater and create leachate. Methane production. When stuff decomposes without it, that's not in the presence of oxygen. So because this is all buried underground, when it decomposes without oxygen, a lot of it. This decomposition without oxygen actually produces large amounts of methane. Methane is a gas that's highly combustible and poses an explosion risk. It's also a greenhouse gas. So now there's ways of dealing with this, with methane production. Okay. I can't remember. Okay. So one of them is to actually burn off, and I didn't pull this off, but I will. So if you ever go up by the landfill up by DeKalb, Sycamore, like along 88 there, sometimes, especially, you can see it during the day, but at night, you can see something like these. Okay, these are vented methane. So what they do is they drill like essentially like wells or some like vent holes into the landfill. They have vent holes made into the land to vent the methane, because if it builds up under, if they don't vent it, it can build up and it creates an explosion risk, because another side product of decomposition is heat. So if you get the heat and the methane, you can actually create huge explosions in landfills. So they have to vent the landfill gas off. So you can see like they'll have different like landfill vents where they have vents and the landfill, but instead of they don't want to release the methane into the atmosphere because it's a pretty bad greenhouse gas. So a lot of times what they'll do is they'll have these torches at the top of the vents and they'll literally burn off the methane. Okay. Now, there are some that are trying to work this and do methane capture where they can actually capture the methane and then turn it into a fuel source because you can burn it and turn it into a fuel source to then create energy from it to help offset the cost. And that's actually even better for the environment and stuff like that. Okay. So, but methane production is a problem for landfills. Settling. Trash sites over time can settle and create uneven landscapes and even sinkholes. These can pose hazards to humans using the land as well as drainage issues with rainwater. Because over time, even though they compact it down a lot, over time, as stuff decomposes and breaks down, it's going to settle, and that can over time create sinkholes. Okay, incomplete decomposition. Sanitary landfills limit the air and water that can get to the waste. While this reduces pollution, it greatly decreases the rate of decomposition of the trash as well. You probably are going to see this when you do your landfills. The sanitary landfill for your decomposition activity, the sanitary landfill is being represented by the one that you had in the dirt, but everything was sealed in the little plastic bag. Okay, you should have noticed a very big difference between the results of that and the results of the one that was just buried directly in the dirt. Okay, this is because things that increase or help decomposition are exposure to oxygen, exposure to water, exposure to sun, stuff like that. And when you limit that, it really limits the decomposition. They talk in your book. Let me see if I can find this. So, let's see. They were talking. Had a little thing in the book somewhere, and it was talking about these students from like Arizona State University or something, and they were going in and like sort of excavating a landfill, and they actually found I don't know where it is in here, but I thought it was in here somewhere. But what they actually found was they were finding phone books from back in like the 50s and 60s that they could still read. Now, think about that. You guys might not have ever seen a phone book, but phone book is printed on like really thin paper, like almost like tissue paper. If you leave that outside, that's literally going to start breaking down and becoming like unreadable in a few days. Okay, especially if it's exposed to any kind of rain or anything. But they were finding them still in readable states, buried in these sanitary landfills from a long time ago, from decades and decades ago. And that's because oxygen, water, and uh, and sun and stuff can't get to it to help it break down. So while the sanitary landfill is a better option because of the way it reduces the pollution can be much more harmful to the environment. It does slow down decomposition a lot, which leads to landfills filling up. Okay. And the fifth one, finding appropriate sites to put landfills. There's an acronym called NIMBY, NIMBY. NIMBY stands for Not in My Backyard. Nobody wants a landfill near them. So most get put in areas with few people or with people that do not have the ability to successfully reject the siting, poors or minorities. So we talked about environmental racism earlier in this semester, about because poor people don't really have the resources and the connections to go through the channels to get things to sort of fight against these things coming in. So they have this problem with like a disproportionate amount of landfills or things like that put in areas with poor and minorities. Okay, now as time goes on, even those aren't really that doesn't even really happen anymore. Now it's really they put them out in the country. I mean, you can see around us, the ones up by 88 and stuff. That's really not near any residential areas, and it's because nobody would want to be near that. Even the sanitary ones, if you drive by any of that, you can still there's a smell. Um, so finding appropriate sites is another problem of landfills. Nobody wants that near them, near where they work or near where they live. Okay, so those are the five main problems of landfills. All right, moving on. Improving landfills. So how do they go about improving them? You've already seen some of the improvements with the new sanitary landfills. Okay, having a leachate collection system, um, putting in plastic liner, stuff like that. So some other things. New landfills are sited on high ground, well above water tables. So what water tables is water table is underground where um, where water, like as it rains and stuff, that's where water goes down, and that's where like all of our like the lakes and rivers and stuff is fed from, and that's where we get a lot of our water. If you live in the country and you have a well, you get what they do essentially is they drill down below the water table, and then the water comes in, and then you pump that water up. Okay, that's groundwater. So new landfills, instead of like digging holes in the ground and potentially getting near ground table, they site them on high ground, well above water tables and underground water areas. The floor and sides covered with plastic liner. We talked about that. Empty leachating into a tile collection system. Okay. Built in the shape of a pyramid and capped with topsoil and seeded. Pyramid shape helps to shed water away from the landfill. So if you have a flat top, then the water can just soak right down through and create more leachate and stuff. But if you have a pyramid form, okay, more of a triangle pyramid, then the water, like think about houses. Okay, houses, the roofs are slanted to help water and snow and stuff shed off a roof. Same thing with the landfills. If they do them in sort of a pyramid shape, then the water can go down the side more easily and not leak through it. And then the last one is another one I've already mentioned, surrounding the entire site with groundwater monitoring wells to help monitor and make sure and catch any potential pollution that might be entering into groundwater. Okay, so for more, in addition to some of the other ones I talked to, things that can be done to help improve landfills. All right, the last part of this is combustion. So combustion is where you actually burning trash. And in your book, there's a okay. They have an image in your book of a waste to energy combustion facility. So in this, the trash comes in. Okay, they inspect through it and make sure there's nothing that can't go in these. It goes through a shredder, and then they pull out some things that can be recycled, like metals, stuff like that. So they pull out metals that can be recycled that are in the trash. Then they send the rest of the trash into essentially this huge burner. Okay, so the rest of the shredded trash goes in here. It's burned off. Okay, anything that wasn't any metals that were left behind that weren't magnetic, that weren't taken to be recycled, will go to a metal recovery system, a different metal recovery system. Okay, and then what they do is now this is a waste to energy combustion facility, so they're actually using it to create energy. So they've got water in here, a steam drum, and what happens is when that water boils, it creates steam, and then that goes and it turns a generator, and that generator creates electricity. So in this one, it's not just being combusted, it's actually that energy from the combustion is being used to make energy. And then over here, this is some of the stuff dealing with some of the other, like the side products of the combustion. Okay, so it's reacting it with lime and other stuff. Then they get like this, it's kind of like a filter, basically, this electrostatic precipitator to get out other harmful substances. And then they turn it in and it runs through all this to try to get what's called fly ash, which is sort of like the remains of anything else that's hasn't been caught by these other methods before it goes out. So it's kind of like filtering it, filtering the gases and stuff that are coming out of the stack. So that's an example of a waste to energy combustion facility. So advantages of combustion can reduce the overall weight of trash by more than 70%. Toxic or hazardous substances are concentrated into two ash streams, which are easier to control and handle safely. So those ash streams that I was talking about at the end there, like anything that's left over hazardous or toxic substances, it's kind of easier to handle because they're in smaller amounts. You don't need to change the public's current behavior of trash collection or procedures, which is a big one because it's a lot of times it's hard to convince people when they've already got something they're used to doing and it's very easy and cheap. 2/3 of combustion facilities have modern emission control technology to reduce air pollution. So we have the technology to actually reduce the amount of air pollution from the combustion of it significantly. Combusted MSW releases 35% as much energy as coal, which can be converted to electricity. That's like I just showed you. Okay. Many combustion facilities also have recycling facilities to remove any materials that can be recycled before the MSW is burned. So that was the beginning part of that. Okay. Drawbacks. Even with the filtering and stuff, it still produces some air pollution and offensive odors. They initially are pretty expensive to build, and you still have siting issues with them. Ash from the combustion is often loaded with metals and other hazardous substances that have to be disposed of in a specific, safe manner. I don't know if this is a huge drawback from combustion because technically you have that with regular landfills anyway, but you definitely have it with this. To justify the cost of operation, facilities must have a continuous stream of trash. And you wouldn't think that'd be a problem. Like, well, we got so much trash. How is that a problem? Well, you have to have it continually coming in to continually burn. And depending on where they're placed, it can be a problem. They might not have enough to continually keep it operational. And then number 5, even if the facility generates electricity, the process wastes both energy and materials unless it's combined with recycling and recovery. So you would need to combine it with the recycling and the energy recovery in order to make it a viable process that doesn't waste energy and materials. Okay. All right. Advantages and drawbacks to the combustion. So a long video, but hopefully that gives you everything you need to go through the homework and anything else. All right. If you have questions, as usual, let me know.